We will now see how to evaluate the average temperature of the coffee during the first 22 minutes, given that the temperature of the coffee is given as a function of time. That is, T of t equals 23 plus 73 e raised to the power of minus kt, and k value is also given as 1 over 46. So let's start to do it. So basically we have to use the formula, that is the average value of a function defined over the interval a comma b is given as average value equals 1 over b minus a integral within the limits of a to b f of x dx. So this is the formula we'll be utilizing to calculate the average temperature of the coffee. So first let's determine the a and b values. Since we have to find the average temperature during the first 22 minutes, so we can say that the a value equal to 0, that is this is in time, and b equal to 22. So these are the extreme values of time which we are going to utilize in the formula. So I write down the average temperature. We write down T temp as for short form temperature. So this is equivalent to 1 over b minus a integral of a to b, and then for our function it is T of t dt. So let me substitute the values now. So I can write down from here. So this is equal to 1 by b equal to 22 minus 0 integral of a is 0, b is 22, and I substitute the value of t of t, which is 23 plus 73 e raised to the power of minus kt, and this has to be integrated with respect to time. I'll be utilizing the value of k later after once I have integrated. So let me put the value of k over here. This is 1 over 46. So let's evaluate this integral. Let's first simplify this. This is 1 over 22. I can write down this as two integrals because we have two parts inside the function. That is, one is 23 and another one is the exponential function. So this could be written as integral of two parts, that is 0 to 22 23 dt plus integral of 0 to 22 73 times e raised to the power of minus kt dt. So now let's evaluate these two integrals. So this is equal to 1 over 22. When we integrate 23, this is basically integration of just dt. So I can put this as like this. I put this big square bracket. Plus here as well I can factor out the 73 using the constant multiple rule of integration. And then I write down this as 0 to 22 e raised to the power of minus kt dt. So let's continue. So this is equal to 1 over 22. Now let's integrate the dt. Notice that integration of dt is just t. So this becomes 23 times of t is 23t. And I have to apply the limits. So I can put this as like this, 0 to 22 plus 73 times of. Now I can use this formula. Suppose if we have to integrate an exponential function like this, e raised to the power of negative ax, where a is a constant, this is equal to e raised to the power of negative ax over negative a. Or in fact, if it is e raised to the power of positive a, it will be e raised to the power of positive ax divided by positive a. So this is the formula. So if we use the formula over here, we can write down this as e raised to the power of negative kt divided by k is a constant over here. I put negative k, and this has to be evaluated within the limit 0 to 22. So let's continue. So therefore this is equal to 1 over 22. Now let's evaluate this first part, that is this part, by substituting the upper and the lower limit. So when you substitute the upper limit, we get 23 times of 22 and subtract 23 times of 0. So this is what we got for the first terms. And here we have 73 times of e raised to the power of negative kt divided by minus k. So I can write down this as maybe I can show up in a different color. that is minus 73 by k is another constant, and then we have to evaluate e raised to the power of minus kt 0 to 22. So it's basically we have to evaluate, or we have to apply the limit only for e raised to the power of minus kt. So this is within the bracket. So this is equivalent to 1 over 22. Can evaluate this using the calculator. So I'm getting 506 when I multiply 23 times 22 minus of 0. So I can just ignore this. Minus 73 over k. Let me substitute the upper and lower limit for e raised to the power of minus kt. So when I do that, I can put a bracket over here. This is e raised to the power of minus k times of 22. This is for the upper limit, and then we put minus and we put e raised to the power of minus k. In place of t, we replace 0. So therefore this becomes like this. So we can substitute here. This is 1 over 22, 506 minus of 73 by k. This is equal to e raised to the power of minus 22k, which is minus 22k, minus this will become e raised to the power of negative 0. In fact, e raised to the power of negative 0 is equal to, using the power rule, we can put this as e raised to the power of 1 over e raised to the power of 0, which is 1 over 1, which is equal to 1. So I can simply put minus negative 1 over here. Now let's continue. So this is equal to 1 over 22, 506. Now you can substitute the value of k, which is value of k equal to 1 over 46. So when you do that, 73 divided by 46, 1 over 46, which is equal to 73 times of 46 over 1. And similarly, e raised to the power of minus 22 times of k is 1 over 46. So this is equal to 46. 22 times of 46 divided by 1, which is simply 22 times of 46. And minus 1 we have. So we can, at this stage, we just have to utilize the calculator to evaluate this. So we have minus 506 minus of, let's calculate the 73 times of 46, getting 3358 multiplied by e raised to the power of negative 22 times of 46. So let me evaluate this quickly using the calculator. This is, first I plug in 22 times of 46. I take the negative of it. Then I raise this to this power, e raised to the power of this quantity, that is e raised to the power of 22 times of negative 22 times of 46. So I'm getting 3.1187 approximately, minus of 1. So when I subtract 1 from this, it looks like I have made a couple of mistakes over here. The first one is, since the value of k equal to 1 over 46, I need to change this to 22 divided by 46. This will become 22 divided by 46. And similarly, this another one is 73 times of 46 is basically 3358. So we then calculate the rest of the things. So this will change. So this will become e raised to the power of negative 22 over 46 minus 1. So basically we have to evaluate this quantity. First we have to plug in 22 over 46 into the calculator and then raise it to the power of e, and then we have to subtract, so we will get some value. then multiply with this negative 3358 and add the result to 506, and then finally we divide it by 22. So when we do, it's just basically another calculator process. We'll be getting the value as approximately 81.023. So this is the average temperature of the coffee during the first 22 minutes.